Most people treat black sand like a feeling. They see a dark streak in the pan and think, this looks promising. Or they don't see it and decide, this place is dead. I used to think that way too, and in my experience, that mindset is one of the fastest ways to waste a day, because it turns prospecting into mood reading instead of evidence reading. Heavy minerals aren't a lucky charm. They're not a guarantee, they're information. They're the river and the landscape leaving you a trail. If you know how to read it, and once you learn to read that trail, something changes. You stop doing one random pan here, one random pan there, hoping the universe likes you today. You start testing like you're following clues. That's what I want to give you in this video. A practical way to use heavy minerals as a trail so you can follow evidence without guessing. Now, I want to be clear right away. Black sand does not mean gold. I've seen places with beautiful black sand lines and not a single speck of gold worth talking about. I've also seen places with almost no black sand on the surface that still held gold at the right layer in the right trap. So the question isn't, do I see black sand? The real question is, what is your concentrate telling you about energy, sorting, and traps? That's the difference between a prospector and a gambler. Here's the simplest way to think about it. Heavy minerals, magnetite, ilmenite, hematite, garnet, zircon, and others, are denser than common sand. They don't move the same way. They settle differently. They collect where the water loses energy and where the riverbed creates natural pockets and catches. Gold follows the same physics, not perfectly, not always in the same ratio, but the same rules apply. So when you find heavies in the right place, in the right layer, and in a repeatable pattern, you're seeing something important. This location is sorting dense material. This location is capable of holding dense material. This location has trapping conditions, and if you're hunting gold, that's the kind of place you want to spend your time. But there's a warning here. Heavies are only useful when you treat them like a trail. A trail has direction. A trail strengthens and weakens. A trail changes when you move a few meters, or when you go down to the base layer, or when you cross from one side of a bar to another. If you don't compare samples, you're not following a trail. You're just looking at one footprint and guessing the whole story. So here's the core rule I work by. I don't chase a good-looking pan. I chase a change. If the heavies get stronger when I move a certain way, that direction matters. If the heavies fade when I move a certain way, that matters too. A single pan is just a snapshot. What you want is a signal that changes in space and depth. That's how you stop guessing. Now, to use heavy minerals properly, you need a clean mental model for what heavies actually indicate. In practical terms, heavies can tell you three things. First, the site has had enough energy at some point to move and sort dense material, often during higher flows, floods, or seasonal pulses. Not necessarily today, but in its history. Second, the site's sorting efficiency. Some places mix everything, sand, light material, heavies, into a noisy mess. Other places sort cleanly by density and size. When you see heavies consistently concentrating in the same type of spot, that's a sign the environment is doing real sorting work. Third, trapping conditions. Heavies collect where the riverbed creates catches. Bedrock cracks, clay or hard-packed contacts, low points, natural riffle textures behind boulders, inside bends, and places where flow slows and drops weight. That's the information you're trying to read, and this is an important distinction I want you to keep. Heavies don't tell you there is gold. They tell you this place can hold gold. That one sentence keeps you rational. It protects you from false confidence, and it also keeps you from quitting too early when the surface doesn't look exciting. Now let me give you an honest comment from my own approach. If I see black sand and I get excited immediately, that's a warning sign to me. Because excitement makes people stop testing. They dig deeper in the same hole. They commit time to a spot before they've earned the decision with evidence. The best days in the field, at least in my experience, aren't the days with the prettiest pan. They're the days where the signal becomes clearer because my testing is structured. And the structure starts with comparison. That's why I rarely trust a single sample. I want to see how the heavies behave when I move slightly upstream, slightly downstream, slightly to the side, or down to the base. Because if the heavies have no pattern, they don't guide you. If they do have a pattern, they can guide you fast. And there's one more point we need to settle before we move on. A lot of people use the word black sand like it's one thing. It isn't. That dark concentrate can be a mix of minerals, and different mixes can mean different things. And the tool most people use, the magnet, can help. Or it can fool you depending on how you interpret it. So next, I'm going to break this down in a practical way. Which heavy minerals matter most for reading a trail? What the magnet test actually tells you and what it doesn't. And how to avoid being misled by a pan that looks heavy, but doesn't give you a direction to follow. Black sand isn't one thing. That's the first correction I had to make in my own thinking, because for a long time I treated any dark concentrate like it was the same signal. It isn't. What you're looking at is usually a mixture of different heavy minerals. Some strongly magnetic, some weakly magnetic, some not magnetic at all. And that matters because if you don't know what you're actually concentrating, you can't read the trail properly. So let's break it down in a simple, practical way. In most river concentrates, the heavy fraction can include magnetite, ilmenite, hematite, garnet, zircon, and other dense grains depending on the local geology. The point isn't to memorize a mineral list. The point is to understand that black sand can be dominated by one mineral in one drainage and be a diverse mix in another. In my experience, the mix is often more informative than the color. A concentrate that's almost pure magnetite can happen in perfectly normal terrain with no gold story at all. Magnetite is common in many volcanic and metamorphic environments, and it can show up everywhere. When that happens, black sand becomes a background noise signal. It looks dramatic in the pan, but it doesn't give you a direction. A concentrate that contains a broader heavy fraction, magnetite plus non-magnetic heavies like garnet or tiny dense grains like zircon, often tells you the site is sorting more than just one common mineral. It suggests the environment is doing more selective work, and that makes it easier to trace changes from point to point. Again, this is not proof of gold, but it's a better data set. Now, the tool most people rely on to interpret heavies is a magnet, and a magnet is useful if you keep your expectations realistic. Here's what a magnet can do. A magnet separates your heavy concentrate into two groups, magnetic material and non-magnetic material. Most of the strongly magnetic material is magnetite. Some other grains can be weakly magnetic, but magnetite is usually the main actor. So when you drag a magnet across your concentrate and most of it jumps to the magnet, all you've proven is that you have a magnetite-rich concentrate. That can still matter, but only if it changes in a pattern. This is where people get fooled. They see a strong magnetic reaction, and they treat it like a gold sign. It isn't. It's an information sign. It tells you what kind of heavies you're dealing with. The real value of the magnet test is not the magnetic part, it's what's left behind. After you remove the magnetic fraction, look at the remainder. If almost nothing remains, you might be in a system where the heavy signal is mostly magnetite and not much else. That doesn't mean there's no gold, but it often means your black sand is less helpful as a trail marker. If a meaningful amount remains after removing magnetics, that tells you the heavy fraction is more diverse. In my experience, that makes the signal easier to compare across spots because you're not just tracking magnetite abundance, you're tracking sorting behavior. Now, there are two questions I always ask when I'm using heavies as a trail. First, is it repeatable? If you see a heavy concentrate once and it disappears everywhere nearby, that's not a trail yet. It might be a pocket. It might be a random patch. It might be reworked surface material. Repeatability is what turns an observation into something you can follow. Second, does it strengthen toward a logical trap? Heavy minerals should increase in places where physics says dense material should settle. Behind boulders, in low points, in bedrock cracks, on a stop layer. If your heavy signal is strongest in random places and weak in obvious traps, that's usually a warning sign. Either you're sampling the wrong layer, or the environment isn't creating stable traps in that spot. This is also where depth becomes non-negotiable. Surface concentrates can be misleading. They're reworked and mixed. They can look good and still tell you nothing about where heavies actually settle long-term. So if you want heavies to guide you, you have to sample the layer that holds them. In practical terms, that means you aim for the base of the gravel. right on bedrock, right on clay, right on hardpack, whatever the stop layer is. That's where dense material tends to stop and concentrate. If you find heavies mostly at the base and they repeat across more than one test point, you're looking at a functioning trap environment. If the heavies are only surface deep and disappear when you hit the base layer, that's often a sign you're looking at a temporary surface effect. Now, I want to add a comment that I think keeps people honest. Heavies are best used as a trail, not as a destination. If you fall in love with the look of your concentrate, you stop moving. You stop comparing, you stop mapping, you start digging emotionally instead of logically. So here's the way I keep it simple. I don't ask, is this pan heavy? I ask, is the heavy signal changing in a direction, and is it strongest where a real trap should be? When you focus on that, the magnet becomes a tool for comparison instead of a tool for self-deception. And once you understand the heavy mix and how to interpret the magnet test, the next step is turning it into a field process you can run quickly. Where to sample, how far apart, how to follow the strongest change, and how to decide when to stay, move, or mark. That's where heavies stop being interesting and start being useful. Start with one rule that saves time. One pan is not a decision. A pattern is a decision. Pick a short section you can actually control. One bar, one bend, one bank exposure, or a stretch of bedrock. Your goal is not to find a good pan. Your goal is to find where the heavy signal increases, then follow that increase until it peaks or fades. Begin at a place where dense material should logically settle. Inside bends, downstream of boulders, low points, natural riffle texture, bedrock cracks, and any clear stop layer like clay, hardpack, or bedrock. Choose one main feature and commit to comparing samples along it. Now run a simple 3-point test. Take one sample at the best trap, one sample a short distance upstream, and one sample a short distance downstream. Keep the sample size the same. Process each one the same way. You're trying to see change, not create the prettiest concentrate. If the heavies spike only at the trap and drop off on both sides, you're looking at a pocket. That can still be useful, but it's not a trail yet. If the heavies build in one direction, especially downstream along a line, you may be seeing a streak. If the heavies look similar everywhere, you're likely seeing background material with no focused trapping pattern. As soon as you can, shift from surface sampling to base layer sampling. Surface gravels get reworked and mixed. They can look strong and still be temporary. The base layer is where dense material tends to settle and stay. Sample right on the contact with bedrock, clay, or hardpack. If bedrock is exposed, work the cracks and crevices because those are the most efficient natural traps you'll find. Keep your comparisons clean. If you use a magnet, use it the same way every time. Remove the magnetic fraction and look at what remains. You're not trying to prove gold with a magnet. You're checking whether the concentrate changes from point to point. If the heavy signal strengthens in one direction, that direction matters. If everything stays the same everywhere, you don't have a trail, you have a background. When you find the strongest point, don't go deeper immediately. Step out and follow the signal laterally. Take 2 more tests at the same base layer. One a short distance upstream, one a short distance downstream. If one side strengthens and the other weakens, you've found direction. Tighten your spacing in the stronger direction and keep moving until the signal peaks. The peak zone is where the ground is sorting dense material most efficiently. And if gold exists in that system, that's where you're most likely to confirm it. Now make the decision with discipline. Stay when base layer samples show heavies, the trend repeats, and the signal clearly strengthens toward a specific zone. Move when multiple base layer tests show weak heavies with no direction, and the black sand is only a surface effect. Mark the spot when the trend looks real but access to the base layer is limited, because a mapped lead is more valuable than another random hole. If you follow heavy minerals as a trail, compare, track, and confirm, you stop wasting time on hope, and you leave the field knowing exactly what the ground told you.